All right, so welcome to a brief intro to regular expressions. Even if you're completely unfamiliar with regular expressions, this is going to be kind of like Regex 101, like a boot camp to get you to know most of all the major features of regular expressions. There's a couple of things, more advanced features that we're not going to have time to go over. If you have questions about those, you can ask at the end. But our main goal for today is going to be trying to unpack this regular expression here on this first slide. And if you already are familiar with it, please don't spoil it for anyone else. But without further ado, let's start exploring exactly what regular expressions are. All right, so first of all, what is a regular expression and why would you actually want to use it? So a regular expression is just a way to it's a declarative way to match against strings. So if you just want to do like a basic substring search, right? You want to see like maybe you want to see if a particular string like hello is in some text, right? Most programming languages will have a method or a function that can do that for you. If not, you can write one pretty easily yourself. But regular expressions goes far beyond that. It gives you the ability to do much more powerful manipulations, much more powerful searches with like variable type things in it, and lets you specify in a declarative way, which is a lot faster than like writing. If you've ever written your own parser for a programming language or a parser for a file or whatnot, regular expressions gives you a much cleaner syntax to accomplish the same thing. You can also use it in most good text editors. You'll have a find and replace. Actually does support regular expressions out of the box. So you can use it there. I'm going to have a demo of that later in the workshop. And it's widely supported. Almost every programming language either has it built in or a library for it. It's great for validating things, and it is fast. So the standard kind of implementation of regular expressions will run in linear time after you compile your regular expression. So that's really awesome as well. You get great performance out of this. Okay, so let's look at a very basic kind of almost trivial regular expression here. So this is just a substring search. So if you this whole workshop is given in JavaScript. If you're using another language, it's likely going to be very similar. You might not have this exact syntax. Many languages you have to wrap it inside of a string. But in JavaScript, you can write a regular expression literal between two forward slashes. So our regular expression is just the word hack. And this will, if you actually use this .test method, so after you make this regular expression, you do regular expression .test against some string, then this is kind of an assertion. It'll be like, okay, does it match this or does it not? So by default, you're just going to get a substring search. So it's going to check, is that string inside? So is hack inside hack? It is. Is it night hacks? Yes. Is it in hack at UCF? It is. Hackathon, it will not match against hackathon because it is case sensitive. Many regular expression implementations will have like a flag you can set if you want it to ignore case, but by default, regular expressions are case sensitive. So that's just kind of your very basic thing. Most characters in a regular expression match themselves. However, this doesn't tend to be very useful, right? Because we already have substring search. So we're going to need some more tools to make that a little bit better. So you have wildcards. A wildcard, the most basic one is just a dot. And a dot can match any character. The only things it will not match are like a new line. So if you like /n or /r in your favorite programming language, it's not going to match that, but everything else it will match. So you can see it does have to match a character. So the first three are all going to match. They'll have some character, and then LO. But this very last one, notice how there's no character in front of that E. So it's not going to be able to match that. You also have this idea of character classes. So maybe you don't want to allow just any character. You just want to allow, a certain out of a certain subset of all the characters. So you can do that with a character class. And the way you do that is you wrap all of the potential options inside of some brackets. So you can see we have C, P, and U inside of these brackets here. And so basically what this will match is anything, it will match C, I, N, E, it'll match P, I, N, E, it'll match U, I, N, E. So anything that has that string within it, it's going to match. So notice it doesn't match What is wine then? Okay, wine is not an emulator. So if you're not familiar with wine, this has nothing to do with regular expressions, by the way. But wine is a program that you can use to run Windows programs that were originally designed for Windows on a Mac or on Linux. And it's really awesome, but one of their taglines is wine is not an emulator because it's actually not an emulator. It's basically a complete re-implementation of Windows APIs. So that's a cool project. If you're on Mac or Linux, you never heard of it before, look up wine. It's pretty cool, but nothing to do with regular expressions. All right. You also have some built-in character classes. So remember, our normal character classes, you can just user define them with whatever characters you want inside there. But there's some built-in ones because there's some common things that people want to do and it'd be annoying to type them out all the time. So you've got /D to match a digit. So anything 0 to 9. /W will match a word character. And so a word character is any letter, any number, or an underscore. And then you have /S, which will match any white space. So it'll match one space, one tab, one new line, all the various different white spaces will match one of those. And then if you capitalize that character instead, it will give you the inverse of that. So any character that isn't that thing. So /D gives you any non-digit. /W gives you any non-letter, non-number, and non-underscore. And /S gives you any non-white space character. So you can kind of see sort of a contrived example for this one. But you can see we're going to match first a white space character, then a word character, then not a white space character, then a digit character, then not a digit character. So C3PO with a space here. So the /S matches our space. C is a word character. And then this hyphen is not a space character. So that matches. And then the 3 is a digit. And then the P is not a digit. And then remember, this is a substring search. So if you have other characters, it's okay. It will still match. We're going to look into ways if you want to limit that and make sure you get sort of an exact match with some later tools we're going to get. But for now, everything's just a substring search. You're also going to get this second example here. It might not be clear, but that is a tab right there in front of our QWERTY with 3. And if you kind of go through it, you'll see that that one also will match. So you can see these are two sort of very different looking things, but we're able to match that with the same regular expression, which this is a really powerful idea. You also have the option to do ranges. So let's say you want to do like the first half of the alphabet. You want to get like A to N or something like that. You could just type out A, B, C, D, E, F, G and go all the way down, right? But that's going to be absolutely horrible to do. So what you can do instead is you have these ranges. So you write a letter. So you can do capital letter ranges. That does not include lowercase letters. So you can also do a lowercase letter range. And this will just automatically include all of the characters in that range. So this A to C gives us capital A, capital B, and capital C. It's exactly the same. You can also do it with numbers. That should be fairly straightforward how it works. This commented regular expression here, I just wanted to show you how an inverse works. I couldn't think of a great example of when you'd want to use this. But what an inverse does, if you put a little caret, so you see that caret inside of our first character class there, then that character class is now inverted. So just like capitalizing the D and the /D or the /S, and it gives you all the other characters that aren't included in that class, that's what the caret does, but just for your own user-defined ones. So in this case, this regular expression, actually the second one, the commented one, will do all the same matches. It's exactly the same because it takes, if you look, so it takes, without the caret, it's all non-word characters, plus all lowercase, plus D, capital D through capital Z, plus 0 to 9, plus underscore. And so it's everything that's not in that. And that only leaves you with A to C, capital A to capital C. So this is equivalent. You would never want to actually do it this way, obviously. But that is the use of the inverse. You can put a caret inside of a character class to prevent that one from being used. Okay. Anchors. These might have different names. This is just a name that I use for it. I believe they're called anchors. But so you might see that caret again. So caret can have two different meanings depending on where it is. Most characters in regular expressions are not like that. So most of the language is pretty simple. This is one case where it kind of is used for two different things. If it's not inside of a character class, then it represents the beginning of the string. So what it will do, let's take a look at this first example here. If we put caret and then R, it will enforce that R is at the beginning of the string. So look, it matches Rob because the R is at the beginning, but it won't match Chris because there are other characters there, right? The R is not at the beginning of the string. So it doesn't work. And the $ does the same thing except for the end. So you can see here, anything that ends in ing is going to match. Yeah, sorry, Chris. It's okay. I have some other slides later that you will like. But getting groceries, because the ing is not at the end of the line, is not going to match. Commonly, you will see people use both because that kind of gives you that, instead of that substring match behavior, you're able to enforce that your regular expression is like the entire expression, right? Because if we put that caret at the beginning, now we're saying, okay, it needs to start with hello and it needs to end with this world exclamation point. So if there was anything else, it's not going to match. So this kind of, you can see, even if we add a space or we add any other text on the outside, then doing that's not going to work. So as a result, you see this sort of thing very common. Okay, we have a question in the chat. What happens if the regular expression is, for example, an R with a caret after it, or a $ at the beginning and then R? If you do that, I'm not sure if it's considered an invalid regular expression, but it's basically just not going to match anything because it just can't be true. So if I think most languages will let you make it. It just will never match anything. So yeah, not recommended. Just use the value false instead of doing whatever you're trying to do if that's really what you want. Okay, quantifiers. These are super useful. So sometimes you want to be able to repeat something an arbitrary number of times or a specific number of times. If you use the asterisk, you can match 0 or more of something. And if you use the plus, then it matches 1 or more. And question mark will either match 0 or 1. So question mark is like, it could be there, it might not, but at most it's going to be 1. The other ones kind of let you get an unlimited amount. The only real difference is plus, make sure there's at least 1. A common use you will see is to see this dot star. So if you take a look at our example here, this may not be like the best email regular expression you've ever seen, but it's a very simple one. We take dot star, and so that will match any number of any character, and then an @ symbol, right? Because there's nothing special about it. It's just a literal @. So there has to be an @ symbol then, and then dot plus. So at least 1 character of anything after that. So you can see it'll match an email, but it will also match my Discord handle, right? Because the dot star doesn't actually have to match anything. It can match nothing as well, which it is in that case. But you can see in our last example, it turns out false. If the plus, make sure there's at least 1. So if we end with @ then it will not match. So this sort of idea, these come in handy a lot because a lot of times you have things that repeat, or that the question mark is great because you might have something that, you want it to be there. It could be there. Some people put it there, but for whatever reason, it might not be present in other input. So these are super useful. There's also some more manual quantifiers. So if one of these like built-in ones isn't for you, that's fine. You can make your own with all kinds of different things. So what you can do is put a number inside of a set of braces. And if you just put a number, then it will force exactly that many. So let's take a look at our second example first here, actually. If we do MO and then this 2 inside of braces here, then what that says is the previous character needs to be repeated exactly 2 times. So if we run it against this moo, it will match, but it's not going to match the whole thing, right? Because it can match substrings because we don't have the caret and $. So it'll still match, and that's why I'm doing exact instead of test. So it'll just match moo. So it's not really necessarily as good as this one. If you do 2 and then a comma, then it's 2 plus as many as you want. So it's just like 2 to infinity. You can also put another number there. So if you only want to allow between like 5 and 7 or any range, then you can do that as well for repeating things. Okay, escaping. So let's say you actually want to use one of these special characters. Like let's say you want to use a $ and like you actually want to match a $ and not have it represent the end of the line. You actually want to use a caret or any number of these things, right? Well, the way you actually do that is you just put a slash in front of it. And then that slash plus the character. So if you take a look at our example, our slash $ here, that's treated as one character that is just literally the $sign and has nothing to do with being at the end of the line. So our regular expression matches a $sign and then a digit, and you see the plus, right? So it matches one or more digits. And then slash dot, this is the one that people forget a lot, but remember, dot matches any character, not just dot. So if you put a dot, this one's especially is common because if you just put a regular dot and expect it to match dot, it does work. But it will also match any other character, which is often not what you want. You just want it to match specifically a dot. So if you just want specifically a dot or a dot literal, then do slash dot. So we're going to match our $sign, then at least one digit, then a dot, and then exactly 2 digits. And this is sort of the template for this is you could match some sort of price. But you have to include the cent. You can see on the third one, right? It doesn't take it if you don't put the dot and something after and 2 digits after. And the last one, you do have to put something in the $sign. And of course, you could write it differently if you wanted to do different things. This is just an example. Groups. Okay, so let's say you want to use some of these cool operators like our question mark or our plus or our star, but you want to use it on more than one character. Well, how do you do that? One thing you could try to do is like put it after each one, but that may not have the effect you want. That will let each one independently be there or not. So if you did like, in this example, if you did F question mark, A question mark, then you could have F, but not A. So if you want it to kind of be together as a chunk, then you can just put it inside of parentheses. So if you use parentheses, then that will group all the characters inside of it and treat it, the regular expression parser will treat it as like one character for the purposes of using all of these other special quantifiers and things like that. So this example, we have our caret, right? So beginning of the line, and then we have an optional fa. So if you look at our very first test, right, it'll still match la la. You don't have to have the fa, but you can if you want. So that's nice. And then it will match some number of at least one la with a space. So this is why our second one doesn't match because we don't have a space after the la. And then also we need to have one la at the end to finish it off. So you can see all the different things that will match. We have our $sign, of course, to enforce the end of our regular expression. So yeah, groups, these are super awesome. Let you use all of your cool regular expression features with a chunk of characters. Groups also have this nice feature of this or. So you can put the pipe character inside of your group and it'll give you can kind of like switch onto different options. So you can see sort of the effect of that here. If we want to say we could have night hacks, we could have swamp hacks, we could have shell hacks, right? Then if you put all those in a group and you put pipes between it, then it will say, okay, it could be this one, it could be this one, it could be this one. Any of those will match. This is great if you have user input, like say you're trying to parse an address or something, and you know people might put drive at the end or dr with a dot. There might be different options that all sort of mean the same thing, but are represented differently. This is a great way to sort of handle that. One pitfall you can run into with this is for character classes. So let me go back to that. People sometimes try to use these inside of a character class. It's very easy to get these sort of mixed up if you're not sure. So remember this one inside of our brackets here. People try to put the pipe character inside here, and it does do something, but not what you think. It doesn't do or. Remember, this one is switching over individual characters already. You don't need to put pipe characters in. If you do put pipe characters in, then what will really happen is it will just treat the pipe character like any other character, and it will say, this character could be C, it could be P, it could be U, or it could be a pipe character, which might not necessarily, it's probably not going to blow up in your face, but it is still a bug because it probably doesn't do what you want. So don't use them inside of a character class. That's not what they're for. This is only a thing used with groups. Okay, so back to that. All right, groups. So by default, groups will do this thing called capturing. What this means is whatever's inside of your group, the regular expression engine can actually remember, like tell you what that value is for a particular match. So let's kind of look at an example of how this would work. So this is probably the most complicated regular expression we've done so far, but let's just break it down. So we start the line with our caret, then we have a group open here, and we have a digit exactly 4 times, and now our group closes. Okay, so this matches 4 digits in a row. That's going to be the year. We're trying to match a day here. Then we have an option because some people write their dates the first way, some people write their dates the second way, right? And we want to let them do both because we want a good user experience. Oh, I don't think we can see the right slide, says someone. Can you see the capturing slide? Does it say capturing? It's the group slide. Interesting. With follow la. Does it still show that? Hold on. I will stop sharing and share again. That's strange.
Zoom strikes again.
I know. We were doing so well this year, and Zoom just decides it hates us every once in a while. Okay. Is that fixed? Do we see capturing?
It says it's stuck in the has started screen sharing thing.
Oh no. Come on, Zoom. You got to be better than this. Okay.
I have a question. Are you wired in? Like, are you using Ethernet or are you using Wi-Fi?
I'm over Ethernet, yeah.
Oh,
It's very strange.
Yeah. Maybe
Okay,
try
well,
unsharing and sharing again.
Tell you what, yeah, I'll leave and come back.
Okay.
One moment. I don't know if that was me leaving and coming back or if that was just sharing the window instead of the desktop, but okay. All right, let's keep moving. Maybe it was because I moved the slides too quickly and that confused Zoom or something. Who knows? This is very strange. Okay, so capturing. So we were looking at this date, right? So we have start at the beginning, then we have this group that will capture and match 4 digits. That's our year. And then we have a character class, right? That can be either dash or / because we want to let the user do either one. Great, that's great. Okay, we have another group, right? So our next set of parentheses there where we're going to match 2 digits for the month. Then we have another one of those character classes to match either the / or the dash. And then we are matching another 2 digits for our day. And then we have the end of the line. Now, you could do this without the groups, right? You don't need the parentheses to do this. We're not using any features that really require it. But why? So why would you want to do this? Well, if you put these in the group and you use this .match, string .match with a regular expression, it will actually give you back a list of those groups that like what actually got matched in this specific instance, which is cool. So the first thing it does is it gives you back the whole chunk that matched, which in this case, because we have the caret and $, right, enforcing that our regular expression is going to match the whole string, it's always going to be the whole string. But then you can see that it's pulling out those individual chunks in the parentheses, but not the things that aren't in the parentheses. And this is great, like what Chris was talking about for cleaning up data, right? So if you have a bunch of dates that are in different formats and you want to make them all the same, well, now you can pull out only the actual data pieces of it, and then you can reprint it into a file or dump to standard out or whatever you're trying to do with just the raw data, and you can insert whatever separator you want to use or put it into a database. You can do whatever you want to do. You can get rid of the formatting and just kind of have the data. So yeah, capturing, you don't always need it, right? But when you do need it, it is a cool thing that groups also do. All right, let's take a look at look ahead. So what look ahead does, so this is actually one thing I want to talk about first. All these things, when I said at the beginning that regular expressions run in linear time, you might have noticed, let me go back slowly so Zoom doesn't get angry. You might have noticed I put a star at the end of that line, right? And I said most regular expressions will run in linear time. Look ahead and look behind are one of the features that can sort of break that guarantee, because they're basically going to make this algorithmically slower. So you actually see some implementations, like I believe Rust's implementation and Go's implementation of regular expressions, your default one doesn't include these because it wants to maintain that linear time guarantee. But most implementations do include these features because look ahead and look behind are something that it's pretty useful. But as a result, they actually do have worse than linear time, even on non look ahead, look behind regular expressions, because I believe they just use the same engine regardless. So there is some fragmentation in implementation of regular expressions. It's not something that's completely like standardized and everyone does everything the exact same way. There's definitely some people who do things in different ways. So yeah, just keep that in mind. Usually don't use look ahead or look behind if you can solve it in a simpler way. It's only something, if you need it, then use it. But don't just use it because you can, because if you can do it another way, it will often be faster than doing it this way. Okay, so how this actually works. the part of it, this slide that is actually the look ahead is your second group there. Okay, so if you take a look at that, you see that question mark. So you have a group basically, and then you do this question mark equals. And then whatever comes after that is it's going to look ahead. So basically it will say what it does is it says it's only going to match the rest of the regular expression if it can look ahead and see that this part is there. But it doesn't match that part either. So let's take a look at this example. So we have university. What this is designed to do is pluck the, is the slide? Can you see the look ahead slide?
Or no, we're stuck on why regular expressions.
Oh no, maybe it is mad because I changed it too fast, but it still shouldn't care, right?
Yeah, maybe like try minimizing your window. Maybe that's it. I don't know. This is very strange.
Yeah, well, Arjun was having this issue before, so it's not just that we had like really difficult things going on. All right, well, let me try it again. This time we'll go back to the desktop. Maybe that will make it happy. Is it loading up? Someone let me know.
No, it's doing the you've started screen sharing thing.
Oh no. Huh. Well, I don't know. I don't know why this is happening. Maybe like Zoom did an update. Yeah, I'm not doing anything. No, all I'm doing is running. This is a JavaScript slides framework, but like it's not heavy. I mean, it should be fine. Plus Zoom and a terminal. That's it. So yeah, it's not a resource problem. Okay, well, I can leave and come back. Maybe that will fix it again.
All right. See you in a second.
Again, maybe we should go to Google. But see, that had problems before again, right? So who knows?
Yeah. Oh, we saw it just now.
Oh, you did for like a second?
Yeah.
That's very strange. Okay, what about now?
Okay, it says look ahead.
Okay. Wow, the Zoom is very fickle. All right. Well, while Zoom is still being reasonable here, let's try to move. Let's try to keep moving. So let me re-explain all of that again, because it's a lot harder without the visual aid. So our look ahead is actually this second parenthesis. So you can ignore that first group for a minute. We'll get back to that. But our look ahead is actually this second group here, where you have this open parenthesis and question mark equals. And so what that does is the question mark equals is the part that's making it into look ahead. What it does is whatever's after the equals, and it doesn't have to, in this case, I did a group because I wanted to switch over some different possibilities, but you can just put a regular match. You can use all of the normal regular expression things there. It doesn't have to be a group. Whatever you put after that equals sign, every character is going to check ahead to see, is that thing there? And if it is, and the rest of the stuff before it match, then it will match. But if that stuff isn't there, it won't match. So why would you want to do this? Well, here's a case here. Maybe you want to strip the street name off of you want to just take the name and you don't want the boulevard or the street or the drive or the lane or whatever that extension is on the end, right? You just want to get the actual name of the road. One way you could do this is using this look ahead. So you have our string University Boulevard, and then we match it against this regular expression. So what actually happens here? So we have this group that just matches any number of characters, and then notice that space. And remember, space is just like any other character, so it has to literally match a space. Okay, so we're going to match in our results. Here's why we get these three results if you're confused. The first result, remember, matches the whole chunk of stuff that matched. So the stuff that matched was this dot star, right? That matched university, and then that space. So that's why you have that space in the string on the second one. And the look ahead part it's not part of a match. Okay, look aheads are never part of a match. So that's why that's our whole match. Then the second one is our first group. So our first group is that dot star. So in this case, if you actually were trying to pull the road name off, you would just want to grab this second element in the array with like a bracket 1, close bracket. And so that gives us it without the space because that's our first group in between those parentheses. And then why do we get this boulevard at the end? Well, that's only because we have inside of our look ahead here, we have another group, and that whatever got matched in that group is now going here. there is a way to make, if you like are confused and you don't want these things to show up, you're like, okay, I'm not planning to use that boulevard. I kind of don't want that to show up. It just makes it more confusing, more likely to have bugs. There is a way that you can get rid of this. It's called a non-capturing group. I didn't have time to fit that into this presentation, but just look up non-capturing group regular expression and you'll find the syntax for it. It's very simple. It's a way to make a group that doesn't capture whatever's inside of it. That way you could just get the one thing you did want. So that's look ahead. Now, we also have a similar concept called look behind. Look behind it's basically the same thing, but it just looks the other way. So here's how you might use it. Let's say Chris goes and gets a PhD, right? But we want to check, like, did he put doctor in front of his name so that we know he actually has PhD? You can use look behind to do this, but we only want to pluck off the name. So we have our string, Dr. Feltner, right? And then we have dot match, and we match against our regular expression. And the only difference between look ahead and look behind is you have this, instead of just question mark equals, you have question mark less than equals. And that less than sort of like, okay, it's going to be behind. That's the difference. And then remember how I told you don't have to put a group inside of a look around, right? You can just do anything. So in this case, we're going to do doctor, and then we have an escaped dot. Remember, this is a common error. You might, if you just put a regular dot, it'll match anything. So it would still work in this case, but it might do bad things in other cases, right? It could match dr anything space, which is not what we want. We only want to match dr dot space. And so that in this case, that does what we want. So it's going to look behind. Every time we go to a character, it's going to look behind and see, okay, do we see this dr dot space? And if we do, then check if the rest of it matches word characters, at least one, and that will be our match. And so you can see we don't do any groups, right? And our match is just going to be Feltner, getting rid of the doctor part. So yeah, look behind. It's basically the same thing as look ahead, but it looks the other way. Collectively, you'll sometimes hear these called look around. Okay, so here's some other stuff that I didn't fit into this presentation because I wasn't sure how we would do in time. It looks like we're actually doing pretty well. But here's some other cool, like more advanced regular expression stuff that you might want to use if you get more experienced or you feel like, you know, this is one thing you really want to do, but you just can't do it with the tools you have. You have back references. That's a way to see what was already captured in other groups. So maybe you want to match something, and then you want to match the same thing that you matched before. And you want that to be able to change from string to string. So you want to be able to match law and then match law again. And then in a different string, you want to be able to match fa and then match fa again. Well, you can do that with a back reference. That's another one of those features that really blows up your time complexity. For most short strings, it doesn't really matter, but I mentioned that because if you expect it to be like super efficient, yeah, it's not going to be super efficient. Non-capturing groups, I already talked about that. That's a way to make your groups not show up in your capture list if you care about that. Named capturing groups, this is purely an aesthetic thing, but if you want your groups, instead of coming back in like an array, you want it to have like a key value. Like you want to, instead of pulling this out into an array with Feltner, you want it to be like an object with name Feltner or something like that. Then you can use named capturing groups to sort of get things named. Negative look around assertions, it's just the same thing as look ahead and look behind, but you can enforce that something isn't present. So let's say we want to make sure Chris isn't a doctor. Well, we can check that there isn't a doctor in front of his name. That's what that does. And then greedy versus non-greedy. A common bug people run into when writing regular expressions is that your star and your plus are greedy. So they will capture as many characters as they can. And sometimes this is more characters than you expect it to. So if you're trying to, like, commonly this shows up when people try to write like an HTML parser in regular expressions, which one is a bad idea, partially because of this. But there's other situations that can come as well. Basically, if you're running into a problem where you think something should match less than it actually is, then you probably are looking at a greedy versus non-greedy problem. And most flavors of regular expressions will have a way to do a non-greedy match. So yeah, that's something to look into. Okay, I did touch on this briefly earlier, but there's a lot of different flavors of regular expressions. So I showed you the JavaScript flavor today. Most implementations are going to have most of these things, like especially all your basic things like wildcards, groups, character classes. But certain implementations, like I said, like Rust, I believe doesn't have lookaround for efficiency reasons. So there might be some things that are different. And there's also some syntax differences. So JavaScript regular expressions, I feel like is pretty standardized. A lot of languages sort of do it in a very similar way, but some languages might escape different things. So one example might be for groups, right? By default, your parentheses are going to match are going to make a group. If you want an actual literal parenthesis, you have to do slash parenthesis. But some implementations of regular expressions might invert that. So by default, a parenthesis is a real parenthesis. And if you want to make a group, you have to do slash parenthesis. And they might do that with any number of different characters. So they might do that for plus. Like I'm going to show you in a minute here. Vim regular expressions by default matches almost everything literally. And you have to escape almost every character if you want the like special behavior. And so maybe you like that, maybe you don't, but just check your language documentation or your library documentation to make sure that what you're doing is actually what you think it does. Okay, so let's go into some sort of examples of regular expressions you might use. The first thing I'm going to do is show you a demo of how you might use regular expression to refactor some code. So let me stop share and let me share my terminal here. All right, can you see my terminal here?
Yes.
Yes, okay, awesome. All right, so this is just a chunk of, this is obviously not working Java, but this is a chunk of Java code I was working on in object-oriented programming the other day with some group members. And with this code, it changed a lot. And before we needed to use like temporary variable names because we had an actual name, an actual ID, an actual GPA, right? We had some things like that were happening. But after we had refactored it down to this point, we realized that we didn't actually need to have this temp prefix in front of everything, right? Just making it more annoying. So let me actually blow this up a little bit so you can see better. So this is, you could go through here. And so like, it wouldn't take me that long to rewrite all these things, right? It wouldn't take that long, but one thing you could do, especially if you have a lot more data than this, is use a regular expression. So Vim has built-in regular expressions. So if I head down, I'm now at the bottom of the window here. The way Vim regular expressions work is first you specify the lines that you want to invoke it over. So we're in line 1, and the whole file is just all the way 1 to 7. So if you do 1 to 7, and then what do we want to do? We want to do a substitution. And then we start our regular expression. So our regular expressions are going to be temp, right? Because we have this temp prefix. And then after that, we want to capture any word characters coming after that. And in Vim, by default, you don't get a group with just one parenthesis, right? You need to escape it. So we're going to escape that, create our group. Then we want to match word characters, and we want to match at least one. So one or more word characters, and then we'll close our group. All right, so we have that. Great. So now we're going to be able to capture that. And then we can do our replace. So our end of regular expression. And the way that works in Vim might work differently in other editors, but you just write another expression that you want to be replaced. So we don't want the temp, so we won't rewrite that. But we do want to access whatever was in that first capture group. And the way you do that in most implementations of regular expressions is a backslash and then 1 because it was the first thing. So we do that. And then if we do the G, so at the very end, we need a G because that makes sure it will do it multiple times within a line. We do that. Oh, didn't find the pattern. That's not good. Hold on. I had this working before. What's the difference? That one works. So what? Hold on. What's the difference here? Oh, yes. Okay. So this is something that's easy to mix up. I forgot to escape the plus. So also you have to do escape the plus. So in Vim, basically every character is just a literal character. So we need to escape that plus. And then you might notice the other thing in my like one that I tested before that was working. This /L in front will lowercase the very next letter of the next thing. So if we don't have that, we just run this. Look, all our identifiers have this capital letter. That's not what we want, right? That's not the standard way to do it in Java. So if we put this /L in front and run that one instead, then it will refactor the way we want. And you see, that's like, it's very fast. And if you have, for this one, it might not be that much quicker to do with a regular expression, especially if you don't have a lot of experience. But if you had, you know, a ton of these, if you had so much data, right? And, you know, hundreds and hundreds of lines, then doing it this way could be substantially quicker. So that's one usage for a regular expression, is use it inside of a editor. Okay, let's look at some other uses of regular expressions. All right, can you see my slides again? Let's see, let me open up chat here. Yes, okay, and the timestamp is right. Okay, awesome, yes. So let's say we want to validate a UCF NID. So this is kind of like that thing that you use to log into like basically all the UCF portals, right? We all know that it's 2 letters and then 6 numbers. So how will we do that with a regular expression? Well, first we want to use our caret and $sign to sort of make sure we match the whole thing. So we do our caret and $sign, and then I chose to make this only match lowercase. If you really wanted it to be able to match uppercase too, you could do that. But in this case, I'm just going to use this character class with a range, remember? So A to Z, that'll make sure it includes all of our lowercase letters. Great. So we match that, and then we want to do that exactly twice. So that's what this bracket 2 after it is. Then we want to match digits, so /D. We want to do that 6 times. And yeah, it's a very, so one great thing about this is if you wanted to actually do this without a regular expression, what you'd have to do is like programmatically walk through this string character by character and have like a bunch of ifs and like maybe a loop to try to make it a little bit simpler. And that's only going to work for this specific case. What if you want to do other things, right? It's going to result in a situation where you have a lot of logic to do something that should be pretty simple to do. And so that's why when I say regular expressions are declarative, you don't describe how to walk through the string and validate it that way. You just describe, here's what the string should look like. And then the regular expression engine does all the hard work of converting that into ifs and all the code that it needs to do to actually figure out if it matches. So this is, if you can't read a regular expression, right, this might look kind of complicated and confusing, but you can see it's very simple. And it's a lot better than writing a bunch of ifs would be.
I had a quick question on that one.
Yeah, sure.
Can you, yeah, okay. So for here, if you did want to have like the first 2 characters as like, let's say both uppercase or both lowercase, would you use like a group with a pipe or something like that?
So if you want, you want to make sure that they're either both uppercase or both lowercase.
Correct.
Okay, so yeah, what I probably would do in that case then would be, I'll sort of type in the chat what I think it should look like. Let me copy this. Yes, basically you're starting to run into some of the limitations of regular expressions because it's not really designed to do contextual stuff well. Like any language that has context is hard for regular expressions to do, but you can get pretty far with like ors and look around. So you can do it. What I would do in this case, yeah, do a group. So we do a group. And then our first option is going to be a lowercase 2, and then we can do an or, and we can do uppercase 2. But honestly, I don't see why you would necessarily want, so it would look something like that. It's probably, without the syntax highlighting, it's going to look terrible, but I guess it's all purple in mine, but it would look something like that. So yes, you can do that sort of thing. But if you're relying on too much context, that's why you can't write a actual compliant HTML parser or XML parser with regular expressions, because anything where you have context going on, where how you interpret a character is going to rely on what happened in the past, you're going to start needing like exponential amounts of back references and ors, which is really going to slow down your parsing, and it's just going to be not something you want to do. But for minor cases like this, if you want to do something like that, you can get around it. I probably would just be like, hey, if they did either enforce it be lowercase, enforce it be uppercase, or just let them do either for both. Like, so you can just do one group that has lowercase A to Z and uppercase A to Z, and let either one be either one. That should be fine.
Gotcha. Thank you.
Sure. Okay. And then, okay, finally, right? So what you came, this is our regular expression that was in all of our marketing, right? What does this regular expression do? I'm going to give you a couple minutes to see if you can figure it out on your own. It might have seemed at the beginning of this workshop completely indecipherable, but I think if you look through it, you'll be able to figure out what it does. I'm going to start walking through it, but if anyone figures out what it is, put it in the chat. Okay, so we have our caret, right? Our caret, that's just the beginning of the expression, so nothing fancy there. Then we have an escaped parenthesis. So remember, that matches a literal parenthesis. And then, yes, this is a great website that Chris is putting into the chat. But see if you can figure it out without it, because you don't always necessarily have to go to the website if you just know it well. So we have this parenthesis, literal parenthesis, and then we have a question mark. So there might be a parenthesis, okay? Then we have a capture group because we have unescaped parenthesis. And we have digits, 3 of them, okay? So 3 digits, then end of our capture group. And then we have a optional, because we have question mark, parenthesis literal. So what we have so far is parenthesis, maybe a parenthesis, then 3 digits, then maybe a parenthesis. And then we match either a space or a dash. Question mark. Yes. Okay, someone got it. Conroy, good job. Yes, it's a phone number. This is it may not be the best phone number, but this handles a lot of cases that people use. So what this will do, right? We've already seen it will conditionally match the parentheses. So you don't have to put the parentheses around the area code. You can if you want to. You can also, so what's going on with our character class here with our brackets is you can either have a space or a dash, or you can have nothing, right? Because it's optional. That class is optional. So there can also just be nothing there. You can have it all the digits right next to each other. And then we have 3 more digits in the capture group. And then we have the same thing where there can be a space, a dash, or nothing. Then we have 4 digits, and then we have the end. And the reason we're putting it on all these capture groups is after you use this regular expression, you can pull out the all the digits, and you'll just have the raw digits without all of the formatting surrounding it. And this is a problem that's going to be horrible to solve with a bunch of ifs and imperative code, but with this declarative regular expression, much easier. Is the area code also optional, or am I reading that wrong? No, yeah, I believe you're correct. The area code's also optional because there's a question mark after that. Or no, it's not. It's not. It almost tricked me, but remember, the question mark only applies to the immediately preceding character, and that parenthesis there, because it's remember it's / parenthesis. So that is a literal parenthesis character, not part of a group. So if that wasn't there, then it would be a whole group. And yes, that'd be optional area code. But in this case, it's just optional parenthesis for the area code. So yes, this is a fairly flexible regular expression for a phone number. And right at the beginning, right, it probably looks like total gibberish, right? What does this even mean? But now you can see, even if you aren't that familiar with regular expressions, you probably can get this worked out, 5 or 10 minutes. You can, go to regexer.com, like Chris put it in the chat, type things in until you figure it out and get this written. And now you have a very robust declarative solution that is going to be, 1, probably much faster, and 2, much cleaner in terms of code than trying to do this by sort of writing your own parser with ifs and stuff. So yes, matches phone numbers, that's the big reveal. And then I just want to acknowledge, without MDN and regexer.com, this workshop would have at least taken me a lot longer to create. But so yeah, those 2 were definitely very important to this workshop. With that, I will take any questions.
Awesome, thank you, Rob. I have kind of a regular expression story. I got this code while we were going over the phone number one, but I had transcripts. Like for this project I was doing, we wanted to take transcripts from political speeches. And you know how in transcripts they have the thing where it says their name and then the time and then the colon. We wanted to get rid of all of that, but there were tons of variations among, because some of it said like President Donald Trump, and some of it said Donald Trump, and some of it said Vice President Joe Biden, and some of it said former Vice President Joe Biden, and all of that stuff. And there were spaces, different numbers of spaces, or the numbers for the time were all different. So I made these really large regular expressions to get rid of all of the different variations, and it worked really well. So if you're doing something like that, that's another situation which regular expressions were I found them very helpful.
Yeah, yeah, for sure. That is like, that's a classic. That's a great use for a regular. Anytime you have text that can be in different formats, you know, like a phone number, I feel like is a great example because people write them in a bunch of different ways, right? My regular expression didn't do this, but you could make one that, like, you know, some people might put a +1 or just a 1 in front of it for international area code, right? You could easily add that with a regular expression to conditionally match that. And it's just, it's really powerful. It doesn't take you that, once you get used to it, it doesn't take you that long to write. And you're going to be able to parse so many things. So yeah, they are really fantastic. That's a great story. It looks like we don't have any other questions. So with that, let's see, let's go ahead and stop recording.